Alright, this screencast is for linear programming. Our example is a farmer can plant up to 8 acres of land with wheat and barley. He can earn $5,000 for every acre he plants with wheat and $3,000 for every acre he plants with barley. His use of a necessary pesticide is limited to federal regulations to 10 gallons for his entire 8 acres. Wheat requires 2 gallons of pesticide, and barley requires 1 gallon of pesticide per acre. So the first thing we're going to do is define the variables. X is going to be wheat, and Y is going to be barley. And the first sentence is the first constraint. He only has 8 acres of land total for both of the crops. So X plus Y is less than or equal to 8. The second constraint comes from the fact that he has 10 gallons and wheat requires 2 gallons and barley requires 1 gallon. So that is 2X plus Y is less than or equal to 10. So here is the available acres, and this is the pesticide. And then we have to write the profit function. And the profit comes in from the second sentence. He has $5,000 for wheat and $3,000 for barley. So the profit function is 5,000 X plus 3,000 Y. And what I want to show you, even though you're not going to be required to do this, is I want to show you what the feasible region would look like on your calculator. So I have the calculator here, and then I actually opened one of the apps. And those of you with the rectangular calculators, if you go into apps, it's the 5th one, the inequalities app. And I don't want to quit it because I already have it open and set up. So I want to go into it, and I have put in the 2 equations in y equals form. So let's go back so I can show you how to write our constraints in y equals form so we can actually put them in the calculator, and that's on this slide here. So remember that we want it to be in the calculator in slope-intercept form, so that means we have to get y by itself. So that is subtracting x from both sides, so we would have y is less than or equal to 8 minus x, because the x's cancel here. And then in the other one, to get y by itself, we would subtract 2x from both sides, so we have y is less than or equal to 10 minus 2x. And then those cancel there. And remember, it's not 7 or 8 because we cannot combine the terms. This 8 does not have an x, so we have to write it as just 8 minus x. This 10 doesn't have an x, so it cannot be subtracted nicely, so we just have 10 minus 2x. So that is what I put in the y equals of the calculator. And right now I'm graphing an equation, so if I push graph, I get the 2 lines here, but what I want to see is the feasible region. So I go back in and I actually can arrow over, and my inequalities are less than or equal to. So if I come down here to y equals, and remember this is in the inequalities graphing app, I want to see the feasible region, and it's less than or equal to. That's the less than or equal to sign, so then I click down, click OK. And I can do the same thing with the other one. Hit enter, scroll down, go backwards or forwards, whichever. Scroll down, hit enter. And then if I graph, I'm actually looking at the inequalities being graphed here. And it's a little bit messy, but we can see this is the feasible region right in here. So, to see the feasible region more nicely, I can actually go back into y equals, and rather than graph what I'm supposed to be looking at, I can graph the opposite. So rather than looking at less than or equal to, graph greater than or equal to, and then I'll be shading the non-feasible region So my feasible region will be very clear. It'll look white. There's not going to be any hash marks over it. I'll be able to tell exactly what it looks like. And let me show you what that looks like here. So now the non-feasible region is being shaded. So the feasible region is this area right here. Very nicely outlined by the axes as well as the blue line and the red line. So this is our feasible region right here. And now we can identify what the corner points are. The corner points are the intercepts. So here's the first intercept. Here's the first intercept here, and the intercept of my blue line, if I go to y equals, the intercept of my blue line is 8. And then the intercept of my red line, I can just count that easily on the graph. Come back to the graph, go 1, 2, 3, 4, 5. So my first two corner points are 0, 8. And then this one down here is 5, 0. Those are my two corner points. And then the intersection point is this point right here, and we can do that. We can do second, calculate. The intersection is number 5. So we're going to calculate the intersection of y1, yes, and the intersection of y2, yes. We want it to guess, yes we do, so we push enter. And the intersection is 2, 6. So 0, 8, 5, 0, and 2, 6, those are the corner points for this particular linear programming problem. And we can test them by putting them back into the profit function. So 5, 0, that's when x is 5 and y is 0. And when that goes in the profit function, it would look like 5,000 times 5 plus 3,000 times 0 is 25,000. Putting 2, 6 into the profit function would be 5,000 times 2 plus 3,000 times 6, and that is equal to 28,000. And then putting 0, 8 into the profit function, that would be 5,000 times 0 plus 3,000 times 8, getting a little squashed there, sorry, is equal to 24,000. So my conclusion for this would be the farmer plants, oh, I can't see. Farmer plants 2 acres of wheat and 6 acres of barley. And he can get a profit of $28,000.